Today we are solving trig equations and inequalities, and we're actually going to start by doing the inequalities. So we're going to have a trig equation, but it's going to be an inequality. All right, let f be, I'm just going to dive in and do examples. And I'll talk through the process as I'm doing examples. Let f be the function defined here. What are all of the intervals of x between 0 and 2 pi when the graph of f is below the x-axis? So we want to know when this is less than 0, so it's an inequality. All right, what we're going to do is we're going to find out between 0 and 2 pi where does the graph hit the x-axis, and then we will do a sign chart to see where it's above and where it's below. All right, that's our process. So I'm going to take f, 2 sine squared x minus 1. We want it to be below the x-axis, but first I'm going to find out where it is on the x-axis, and then we will use those values. I'm going to add 1 to the other side and then divide by 2, and we get sine squared x is positive 1/2. Now I'm going to square root both sides, and when we square root both sides, we will get plus and minus the square root of 1 divided by the square root of 2. And when we rationalize that, we get plus and minus square root of 2 over 2. I am looking at all of the pi over 4 angles, right? So between 0 and 2 pi, I'm looking at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So those are the values where it is on the x-axis between 0 and 2 pi. So here's 0, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and then we stop at 2 pi. Alrighty? So we want it to be below the x-axis. So I know I do not want to actually include the spots where it is on the x-axis. I'm going to have to determine if I want to include 0 and 2 pi when we are doing our sign chart. We're doing a sign chart here. Okay, so we're doing a sign chart. So I'm picking values. I'm going to pick values. I'm going to start by picking a nice value. Let's get a nice value. I'm going to get a nice value. I think in here I see that pi over 2 would fall in there, and pi over 2 is a nice value. So I'm going to go back to my initial f. I'm going to go back to my initial f, and I want to know, is that positive or negative at pi over 2? So if I put that in, I'm going to have 2 times sine of pi over 2 squared. Well, sine of pi over 2 is 1, and when you square that, it's still 1, minus 1. That is 2 minus 1, and that is positive. So this section right here is positive. What is a nice value in here? Well, a nice value in there is pi over 6. So I'm going to do the same thing. 2 times sine of pi over 6 is 1/2. And then I'm going to square that and then subtract 1. That's going to be 2 times 1/4 minus 1. That's 1/2 minus 1. That is negative. So this section here is negative. And that's pretty much what I expected. We know kind of that sine is most likely oscillating here, right? So we could keep on going to verify that. I could keep on going. If I pick a value in between 3 pi over 4 and 5 pi over 4, pi is in there, right? So if I pick pi, I'll have 2 times sine of pi is 0, minus 1. When you square 0, it's 0. That's 0 minus 1, and that is negative. So as predicted, that one is negative. Negative, positive, negative. We expect the next one to be positive, correct? We can verify that. 5 pi over 4 and 7 pi over 4 3 pi over 2 is in there, right? So if I pick 3 pi over 2, I'll have 2. Sine of 3 pi over 2 is -1, but we're squaring that. Minus 1, that is 2 minus 1, and that is, as predicted, positive. I'm sold. I'm just going to make this a negative and be done with it, all right? I'm not going to keep checking. So what about right on the boundaries? What about right at 0 or right at 2 pi? Well, I can check that. If I check that, I'm going to have 2 times sine of 0 squared. Sine of 0 is 0, squared is still 0. We have 0 minus 1, that is negative. That is negative. So do we want to include that or exclude that? We wanted it to be below the x-axis. We want to include that, right? Let's do the same thing with 2 pi. Hopefully you see that 2 pi would give us the same answer as 0 because the only trig function here is a sine. So that's going to be also negative, which we want to include. So my answer here to this kind of long problem, my answer, what are all of the intervals? I want to keep all of the negative intervals. So 0, including 0, to pi over 4, not including pi over 4. And then again, from 3, so union with 3 pi over 4, not including that, to 5 pi over 4, not including that, and then again union with 7 pi over 4, not including 7 pi over 4, to 2 pi, including 2 pi. So these are the intervals between 0 and 2 pi where the graph of f is below the x-axis. Let's do another one. Determine all the intervals between 0 and 2 pi that satisfy this inequality. So once again, I am going to set it equal to 0 first. See where it is 0. This time we're going to include those, and then do a sign chart to see where it is greater than 0. So this time we're going to be keeping the positives because we want it to be greater than 0. Okay, I'm going to use my trig identity. Sine of 2x is 2 sine x cosine x. And now I'm going to factor out a cosine x. This gives us that either cosine x is 0 or 2 sine x minus 1 is 0. Well, cosine is 0 between 0 and 2 pi at the pi over 2's, right? So pi over 2 and 3 pi over 2. For this one, I'm going to add 1 to the other side, then divide by 2, and I'll have sine of x is 1/2. So that is in quadrant 1 and 2 where sine is positive, and x will be pi over 6 and 5 pi over 6. Okay? So I have 4 values between 0 and 2 pi where this is equal to 0. So on my sign chart, on my number line, I'm starting at 0 again. I'm ending at 2 pi, but I'm going to have all 4 of these in between. So what is the smallest value? The smallest value here is pi over 6, so I will start there. The next largest value is pi over 2. I'll put that on my sign chart. The next largest is 5 pi over 6. The next largest is 3 pi over 2. And I need to keep on going because I need to end at 2 pi. All right, this time we are going to include these intermediate values. I don't know yet whether or not to include 0 and 2 pi. They aren't my knowns yet, so I'm going to leave that open for right now. We'll come back to that after we do our sign chart. Okay, so let's get a nice value. Let's see, what's a nice value? I think I'm going to get in between 5 pi over 6 and 3 pi over 2 is pi, so I think I'll use pi. So I'm coming back to our original. So that's going to be sine of 2 pi, sine of 2 pi, minus cosine of pi. Well, sine of 2 pi is 0. Cosine of pi is a negative 1. That's going to make that a plus 1, so that's going to be positive. This is positive in here. Okay? Now, I will tell you guys, technically speaking, we should test every other boundary, every other interval. However, this is not a topic on the AP exam, inequalities with trig functions. And for our purposes, you guys, I have created these problems such that we will always alternate in sign on our number line, okay? With trig functions, it does not have to do that, but I've created ones that will. So I'm just telling you, since it's not on the AP exam, we're going to go light on this topic, and when we test all the other intervals, it will alternate signs. So if it's positive here, it'll be negative there. If it's positive here, it'll be negative here. Negative, positive, it will alternate. Positive, negative. Okay? So we wanted greater than 0, right? We wanted greater than 0. 0 and 2 pi were not where it was equal to 0. So if it's negative here, it's going to be negative there. And we don't want negative, so that's an open circle there. If it's negative here, it will be negative at 2 pi as well, so we don't want that either. We want only the positives, so we want positive and positive. There's only 2 intervals where we're above the x-axis, where we're positive. So my answer here, I'm going to have pi over 6 to pi over 2, including both of those, union with 5 pi over 6 to 3 pi over 2, including that. All right? Number 3. Here's f, here's g. Determine all the values of x between 0 and 2 pi where f is less than g. So I want f to be less than g. If I take this little inequality right here and solve it for, get everything on one side, I'm going to move the g of x to the other side, and then I will have f of x minus g of x is less than or equal to 0. I'm doing that to get 0 on one side so that I can do a sign chart like we've been doing. So get 0 on one side. Now it becomes cosine squared x, that's f of x, minus 2 cosine x, that's g of x, is less than or equal to 0. So we're going to find where it's equal to 0. We're going to do a sign chart just like we've been doing. So I'm going to take this and factor out a cosine. I'll be left with cosine x minus 2 is equal to 0. I'm finding where it's equal to 0. This gives me cosine x is 0. This gives me cosine x minus 2 is 0. Well, cosine is 0 between 0 and 2 pi at all of the pi over 2's. Pi over 2, 3 pi over 2. Solving this, I get cosine of x is equal to 2. And cosine of x is never equal to 2. The most cosine of x can be is 1. So no x would give us cosine x is 2. So the only 2 x's that make it true are pi over 2 and 3 pi over 2. So those are the 2 that I'm putting on my sign chart. I'm starting at 0 because they told me to. Pi over 2, 3 pi over 2, and 2 pi, ending at 2 pi. Alrighty, let's pick a nice value of x to put in. I see that pi is available, so I'm going to use pi. Another nice number would be pi over 6, I guess, maybe, but pi is even better. At pi, we're going to get a 0 or a 1 here for cosine, so, or a negative 1. Alrighty, so I'm going back to this right here. Back to that right there. I have cosine of x squared. Well, cosine of pi is negative 1, but then we're squaring it. It'll be a positive 1. Minus 2 times cosine of pi, and cosine of pi is negative 1. That is 1 plus 2, and that is positive. So this is positive. Therefore, like I said, I've created problems that are going to alternate in sign. So this is going to be negative, and this is going to be negative. We want negative. We want negative or equal. We want negative or equal. So equal and equal, right? Negative here means it will be negative at 2 pi. Negative at 2 pi. Negative here means it will be negative at 0. Because 0 and 2 pi were not where it was equal to 0. So I want this interval and I want this interval because of this sign right here. I less than or equal to 0. So my answer, my interval answers will be 0 to pi over 2, including both, union with 3 pi over 2 to 2 pi. And that's how we handle inequalities with trig functions. Okay? I have some more. I think we may have, I don't know if we've done these yet. Okay. Let w be this function, 2 sine of 2x. We want to know the values of x between 0 and 2 pi at which w is equal to 1. We want w to equal 1. So I have w of x, which is 2 sine of 2x, and it must equal 1. Now, we have some options. With trig functions, we many times have options. I could get the sign by itself. I can divide by 2 and get the sign by itself. Or I can use a trig identity for sine of 2x and make it sine 2 sine x cosine x. And we'll tell you, if I do that, in fact, let me show you. If I do that, I would have 2 times 2 sine x cosine x is equal to 1, which would give me 4 sine x cosine x is equal to 1. What do I do with that? The only thing that I could do is bring this to the other side, because you have to get, if you're going to solve this by factoring, you have to get 0 on one side. And if I did that, I would have 4 sine x cosine x minus 1 is equal to 0. How does that factor? It doesn't. So that method did not work. We did nothing wrong, it just did not help us solve this equation. So instead, I'm going to divide both sides by 2. I'm going to get sine of 2x is 1/2. Okay? Sine of an angle, sine of some angle is 1/2. How do we solve sine of some angle is 1/2? Well, we know the angles that make sine a half between 0 and 2 pi. Pi over 6, 5 pi over 6. So that angle is pi over 6 or 5 pi over 6. The difference here is that that angle is not a plane x. That angle is a 2x. So instead of saying x equals pi over 6 and 5 pi over 6, we must say 2x is equal to pi over 6 and 5 pi over 6. Okay? Now, we're not done, because they didn't ask us to find 2x. They asked us to find x. So what do we do to get x? We divide by 2. Same thing as multiplying by a half, right? If I multiply both sides by a half, I'm going to show you something here. I'm going to multiply both sides by a half. However, I know what's coming. I know what's coming. So I'm going to put a parentheses here and a parentheses way over here. And I'm going to multiply both sides by a half. I'm doing that for a reason, you'll see in a sec. Then I get x equals. And I get x equals pi over 12, because you're multiplying by a half, and 5 pi over 12. Here's the problem. We needed all the values of x between 0 and 2 pi. Did we get all the values of x between 0 and 2 pi that make this true? Let me show you on a graph. Let me show you on a graph. 2 sine of 2x. And I'm going to set my window between 0 and 2 pi. There's 0 and 2 pi. Let's see how many answers we need to get. How many times was, we needed it to be equal to 1, so I need to set y2 equal to 1. How many times does w equal 1? 4. There are 4 answers. We only got 2 of the answers. So here's the thing. When you have a 2x instead of a plain x, you need to double the number of answers that you originally get between 0 and 2 pi. Between 0 and 2 pi, double the number of answers by adding 2 pi to each of those. Add 2 pi to get another answer. If I add 2 pi, I get 13 pi over 6. Now I add 2 pi to the 5 pi over 6. Add 2 pi. So adding 2 pi, you're adding 12 pi over 6. That'll be 17 pi over 6. So that's why I have put the end of the parentheses over here. Then when we divide by 2 or multiply by a half, we're going to get 13 pi over 12 and 17 pi over 12. So this was pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. So 2x doubled the number of original answers. If you have a 3x, you'll triple the number of original answers, and so forth. If you have a half x, you would actually end up, one of these would end up being too big and you would only keep the first one. Okay? All right, number 5. What are all the values of x between 0 and 2 pi that satisfy this equation? So we have tangent squared of 2x minus 3, and we need that to equal 0. Okay, I'm going to add 3 to the other side. And now I'm going to take the square root of both sides. Square root both sides. When we square root both sides, we get plus and minus square root of 3. Plus and minus square root of 3. Positive and negative, so we are in all 4 quadrants, right? All 4 quadrants. So the angle 2x is equal to all of the pi over 3 angles. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All 4 quadrants, but we have a 2x. So we add 2 pi to each of these to double the number of answers. So I'm adding 2 pi. Since the denominator is 3, I'm thinking of 2 pi as 6 pi over 3. Add 6 pi over 3. 7 pi over 3 for that one. Add 6 pi over 3. 8 pi over 3 for this one. Add 6 pi over 3. 10 pi over 3 for that one. And finally add 6 pi over 3, 11 pi over 3. Now, solve for x. We're multiplying both sides by a half. So we get that x is equal to, I'm multiplying by a half, pi over 3. This would be 2 pi over 6. I think of it as the 2's reduce, and I'm left with, oops, I said 6, but I wrote 3. Pi over 6 for that. I think of this as the 2's reduce, I'm left with pi over 3. For this one, the 4 and the 2 will reduce, I'm left with 2 pi over 3. 5 pi over 6. 7 pi over 6. 4 pi over 3, because we have to reduce. 5 pi over 3. And lastly, 11 pi over 6. Notice, you guys, that all of these are between 0 and 2 pi. That's our answer. Okay, one last one. How are we doing on time? 26 minutes. Yep. Alrighty, I knew this was going to be a little bit longer. Okay, let f be this function. Let's find the values of x between 0 and pi. 0 and pi. That's going to alter things a little bit. So we need to make sure that our answers don't go over pi. All right? At which f of x is 3. f of x is 3. So we have 4 cosine squared of 3x is equal to 3. I'm going to begin by dividing by 4. So cosine squared of 3x is 3/4. And now I'm going to square root both sides and get cosine of 3x is positive or negative square root of 3 over 2. Positive or negative, so we are once again in all 4 quadrants. So 3x is equal to all of the pi over 6 angles, because cosine is square root 3 over 2 at all the pi over 6 angles. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, right? We have a 3x. So if it was to 2 pi, I would need to triple the number of answers, right? I would need to triple those. But it's not 2 pi, it's just a pi. So here's how I'm going to handle that. I'm not sure how many more I'll need, if any. I'm going to do plus dot dot dot, and I will play it by ear in a moment. We are going to use a pattern here. This is another way we could have done that. Okay? 1/3, 1/3. To get x by itself, we're supposed to solve for x, not 3x, so we're not done. Okay, x is equal to, so I'm multiplying by 1/3, so this will be pi over 18. This will be 5 pi over 18. So here's the thing, you guys, I don't want to go past 18 over 18. I don't want to go past 18 over 18 pi. Okay, 7 pi over 18, 11 pi over 18. Do I need to go further? Maybe. So we're going to take this pi over 6 and add 2 pi to it. We're adding 2 pi to it, and we would get, so we're adding 12 pi over 6, so that would be 13 pi over 6, right? So this would be 13 pi over 18. Let's keep going. We're going to add another 5 pi. Oh, we're going to add another we're going to add 2 pi to 5 pi over 6. So that's going to be 17 pi over 6. So that will be 17 pi over 18, right? What would happen if we went one more? If we went one more, adding 12 pi over 6, we would get 19 pi over 6, right? When we multiply by a third, that's going to take it over pi. So these are our answers for that problem. Okay, so that's how we handle problems where we can't use an identity and get 0 on one side, factor. This is one where we did not solve by factoring. We had no factoring going on, right? Instead, we solved it this way.